Hello, everybody. Welcome to the new year and a new meetup. Thank you, everyone, for coming. It's good to see everybody here. Hope everyone's having a great start to the new year. I mean, you got to be you're at an R meetup to start off the new year. So, I mean, can't get much better than this. Hope everyone is having a, I guess a wonderful time, wonderful day too, or evening, depending where you are. I know most of us who are from the New York area are in the evening. If you're from around the world, have a good day or afternoon, whatever it may be. So thank you for everyone coming for starting off the year. I am really excited about this. As usual, we will start with jobs. Now, of course, the failing there is that unlike when we're in person, you can't all announce what jobs you have available. But if you go to the Slack, the meetup Slack, the nyhackr.slack.com, and you go there, there is a channel just for jobs. Recently, Blue Rose Research and our studio posted, Online Med Ed posted, and it's going on and on. There's lots of jobs posted. So if you're looking for a job involving data science, go to the job postings of NYHackR. Since I am on screen, I am looking to hire for my company all sorts of roles. Looking for a salesperson who is technical and understands the inner workings of data science, or at least the outer workings of data science. We're looking for Shiny developers. We're looking for systems engineers, someone who's good at Linux. We're looking for a project manager, and we're looking for a data scientist. All these jobs could be full-time or part-time, in New York or remote, whatever you folks are looking for. So if you're interested in one of those many roles I listed for Lander Analytics, message me. You can find me in the Slack. You can find me on Twitter. You can find me by email. Many, many, many ways to get in touch with me. So again, lots of positions. Most of them are posted at landeranalytics.com/careers, but not all of them. We need to post the rest of the jobs. But again, looking for sales, Shiny, data scientists, systems engineers, project manager, whole bunch of roles. As usual, pizza. My pizza came from Village Pizza. It had terrible cheese lock when I got it, but it's been sitting around for a little bit. You see, not too much charring on the bottom. It is a gas deck oven, so it didn't char too much. So folks, sound off and let me know where you got your pizza from. I'm always interested in seeing where you got your pizza or other lesser food. I'm very happy to always see what you folks have. I'm always looking forward to this. And one day, hopefully soon, we will all be eating pizza together. We don't quite know when yet, and I'll cover that in a little bit, but hopefully someone could eat pizza. I see John makes his own pizza, which is very cool. You need to send a photo in the Slack. Send us a photo of your pizza. In fact, everyone, that's one of the things. If you have questions for the speaker, you obviously can't all ask questions because none of you can speak, unfortunately. Well, none of you can speak in this meeting, unfortunately. So if you go to our Slack, and we will post a link how to sign up for it if you don't have it, and go to the monthly meetup chat channel. You can ask questions there, and I will collate them and ask ZJ these questions at the end of the talk. So please, if you have questions, go there. Or if you want to post pictures of your pizza or whatever food you're eating, put that in the monthly meetup chat as well. Let's make this as social as it is normally when we are in person. I'd like to thank EcoHealth Alliance for providing us with this Zoom link. They've been doing this for nearly 2 years now. So thank you very much, EcoHealth, for helping us reach everyone around the world. A few upcoming events. Next month, we will have Hans speaking about DuckDB. For those who don't know, DuckDB is this new, I was about to say it's new, but I'm not sure how new it is anymore. It's a database. It's sort of like SQLite, but it's really meant for scientific computing, and it can use Parquet as a backend, or as an Arrow. I get a little confused. That's why Hans is going to be speaking. We're very excited to have Hans speak, and this is actually going to be a bit of a theme we have. We have disk.frame today. We have DuckDB next month. We had Arrow not too long ago. I think we had one other one also. We have a theme of these extra memory data manipulation libraries. So February, I think we have a date, February 24th, I think, but we'll announce it and it'll be an official date. Then in March, we have Bill. He's spoken at a few of our meetups before, and he will actually be talking about the Brooklyn Bridge and how it relates to data science. So that's going to be a very cool talk. So come check out Bill in March. Then in June 8th through 10th, we have the New York R conference. I know it feels like we might have just had it back in September. We had the Gov conference in December. We are actually planning far in advance now for June 8th through 10th, the New York R conference. We are planning on it being in person and virtual. It will be both. and I'm very excited to have it both in person and virtual. Now, we said that last year, it was going to be in person and virtual. And I think at that point, it was the Delta variation that hurt us. Then we said that our government conference would be in person, but then the Omicron variant hurt us. So we are planning to be in person June 8th through 10th. If it's not safe, we have learned to pivot like that in 2 weeks' notice. Hopefully it'll be both virtual and in person. The official announcement is coming out next week. Tickets will go on sale of early bird specials. You can get tickets at rstats.ai, and you can use code NYHackR for a 20% discount as members of the meetup. So we are really looking forward to having this in person, hopefully. Speaking of in person, we are hoping that the meetups can return in person fairly soon. We were hoping for last year, then we're hoping for January, then we were hoping for March, now we're hoping for April or May. Again, we'll return to in-person and virtual. We'll do both. It'll be both in-person and virtual as soon as we can. To that end, we need space to host us. I know a lot of companies aren't ready to host in person, and we're not ready to be in person. But as soon as we are ready, we would like spaces. So if you can host us for the meetup, we're talking about 100, 150 people, let me know. Message me at jaredlander.com, on Slack at landeranalytics.com, on Meetup, find me on LinkedIn, find me on anywhere. Let me know about having space. We've had lots of gracious hosts in the past, and we hope to return to them, but it's always good in a city like New York to have as many hosts as you can. So please let me know if you can host us. Please welcome from almost as far away around the world from New York as you can get. I think there's a few other places a little bit farther, but please, everyone welcome ZJ to talk to us about Diskframe. I'm gonna give an applause since you can't hear anybody else.
All right, great. Thank you very much, Jared.
Thank you.
Today I'm going to talk about the Diskframe package. So I've chosen the title, Your Laptop is More Capable Than You Think. And Diskframe is really just a R package for manipulating larger than RAM data. So I think a typical laptop nowadays has about 16 gig of RAM and 32 gig of RAM and multiple cores. And I always get the feeling that a lot of the programs were written in the days before multiple cores were available or before large amounts of RAM was available. I remember, not that long ago, maybe it was a lot of laptops were still 32-bit, so they couldn't have more than 4 gig of RAM, so it's very limited. But today most laptops are 64-bit, and they can have a lot more RAM. So 16 gig RAM, 32 gig RAM are becoming just the norm. So, and with that much RAM coming on board and having more CPU cores on your laptop, are we able to manipulate larger data sets than we're sort of accustomed to in the past with R? Because as we know, R tends to just load the data into memory, and if it doesn't fit, it will throw some error like cannot allocate vector of this size, etc., etc., etc. So Diskframe is designed to solve those type of problems. And as we all know, like if you work in analytics, probably 80% of your time probably spent on data cleaning and wrangling. And I wanted to just start by giving this slide on the definitions that I want to talk about today. So I think of data as in kind of 4 categories. So you got your trivial data. So these are data that's kind of so small they can fit into Excel. So typically less than 1 million rows. You got your small data, which are basically data that can fit into your RAM. So basically anything that you do in R, like data frames, data tables, or in Python, you do pandas. So these typically would load the data into memory. So classify anything that fits into memory nowadays is small data. And then, of course, you got your big data, where these data are just so huge that you really need a distributed cluster to handle effectively. And I think tools like Spark or in Python, things like Dask would fit into this category. But really, that's a really huge section of data that really isn't that big. It doesn't require a huge, big data framework to handle. They kind of can sit in your hard drive, which is, could be anything like 1 terabyte, 2 terabyte, but you just don't have enough RAM to handle them. And this category of data really is what I call the medium data. And they are a very big chunk of the data science world. Like the banks I work for For example, the credit card data set would be maybe 20 gig, 50 gig, 100 gig. They kind of fit squarely right in there. And we used to just use laptops to run through 50 gigs of data using some programs. So it's definitely not big data. You can definitely do it on one computer, but they're not small as well because they can't really fit into memory. So the medium data is the section that we really want to focus on. And this is where Diskframe plays in. And in this presentation, I really want to touch on a little bit about Arrow and DuckDB, which has already been mentioned by Jared. They're really, really interesting and exciting tools that are coming into that you can work with in the R space. So I guess the ideal medium data tool is, to me, is free, fast, and easy to set up. And I hope a lot more, I hope a lot more of these can work. I just got a quick question about the curly braces for Arrow. It doesn't really mean anything. I sometimes just put square arrows around R package names. So, but sometimes it's not consistent. That's just to indicate that it's an R package. Okay, so I have not done a lot of benchmarking. So I've benchmarked Diskframe versus Dask on one benchmark, and and based on that, I think that Diskframe is slightly faster than Dask in some tasks, but I do not have a lot of data on that. Now, Arrow and DuckDB are kind of newer players in this space, and I think even though I put them on this chart, I actually haven't tested them that extensively. So they're really just a placeholder, but I really hold them in high regard. I think I look at them, they're really promising. So, but really that's kind of what you're looking at in terms of the market, so medium data tools. You can use Spark for this kind of data set. You can run Spark on one node, but it, in my experience, becomes a bit clunky, and it's kind of a little bit of an overkill. And of course, if your enterprise has SaaS, that tends to be the slowest and obviously the most expensive option because it's paid for. So enough background. So I want to just talk about a little bit about Diskframe now and probably give you a demo. But before I give a demo, I think Diskframe is actually really simple. The Diskframe format is nothing but a folder, and inside this folder you will have files, labeled from 1 to n. In each of these files, as you can see, it's a .fst file. So .fst is a data frame storage format, just currently that's only in R, and it was there long before Parquet was a viable option in R. So that's why this one was developed with FST as a really fast format for storing data frames data. It loads fast and it compresses it, and it's got some really nice features. So really, that's really what it is. Just a Diskframe. It's a folder of .fst files. Each file is, of course, a data frame. Stores a data frame, and it's got maybe a metadata folder that contains some information about the Diskframe, but that's basically just it. And the key ideas behind Diskframe is that, as you saw, we have a lot of small files in a folder. So basically, really what it does is it takes a big file and cuts them up into smaller pieces. And there's some good reasons for doing that. One is that if you cut them into smaller pieces, then you can have each CPU working on each distinct chunk. So you can enable parallelism. So you can think of a lot of the operations in your data frame, like filter. Like you don't have to filter sequentially, 1 billion rows of data. You can just filter each of the chunks separately, and you still get the same end result. So you can actually do, for example, things like filter in parallel, unless, of course, you depend on things like the previous row and things like that. But those concepts don't exist in a large data frame frameworks like this. And of course, as I mentioned, if you cut them up, you can do them use all your cores at the same time. And one of the most expensive things you can do on a computer is actually to work with the disk, whether you have a hard drive, a spinning disk, or a SSD. Loading data from disk into memory is actually very expensive. So it actually makes sense to compress your data before you shuffle them around, from disk to memory. And FST is great for doing that, and formats like Parquet are great for doing that. And of course, once you've got your data into smaller pieces and chunks, you can apply online algorithms or big data algorithms to operate on at the chunks one at a time. We'll see, hopefully see a couple of these examples. Okay, and really just want to say that Diskframe really couldn't have been built without the giants in the R fields like data tables, Future, which is great for distributing your processes. Of course, FST is a great format for storing data frames, and of course the tidyverse, which I kind of just use. Okay, so enough about Diskframe. I just want to go to a demo. But really, the main reason I built Diskframe was when I was consulting at a big bank in Australia, one of the biggest banks here. They were using SAS, and were like a really simple group by from a table. Like literally, that's the equivalent of the SQL statement that I was doing, just summing up from some column from this one big table, which is about 50 gig in size, was taking 25 minutes, just a simple query like this. And if you want to do a typical analytical workload, you want to do lots of queries like this, and interactively, it's just not viable. So that's how I ended up developing Diskframe, and the same query was dropped to 3 seconds. So before I go any further, I just show you a quick demo of Diskframe in action. So this is my RStudio. I hope the font is large enough for everyone to see. So really, what I have done here is I have a directory of files, and I'm just computing the total size of these files. It's about oops. Probably should have done the format first. So it's about 190 gig of CSV files. So where does this file come from? This is the Fannie Mae dataset. You can find the Fannie Mae dataset just by Googling, I think, Fannie Mae Rapids AI. So they provide a download of this mortgage data. So you can just go to this data and download the biggest dataset that you see. In compressed form is about 23 gig, but uncompressed is about 195 gigabytes of CSV, and it's got about 1.8 billion rows in the dataset. So that's the dataset I'm working with. So the first step you do is currently Diskframe has to work with .fst files. So if you start with some CSV files, you have to convert them to this Diskframe format. And the way you do that is just to use the CSV to Diskframe function from the Diskframe package. Literally, all you do is you just pass in the names of the CSV files. So these are all the CSV files in the dataset, and it's 190 gig of worth. And that's it. You tell it where to store the data. You can shard the dataset by loan ID. I'll explain the shard concept later on. And these options, if you use data tables, you recognize them from data tables. It's just because this data set actually comes with no header and so it's better if you kind of provide Diskframe with what are the classes of the columns and what are the column names you want to call them. And all of these are set up here where I said, well, the columns are these ones and the classes are character, numeric, and these should be the column names. So that's it. That's just to help Diskframe to kind of get the correct types and get the correct names. And yeah, and I just ran that to convert all the CSV to Diskframe, and it took about in total 20 minutes to convert 190 gig worth of data, and it compressed everything down to about 20 gig in Diskframe format. So it tells you where the Diskframe is stored, and this is just a printout from running this function. So let me just run that. So I ran that last night. So this is what you end up with. You end up with lots of .fst files, 145 worth of them, and they would be around, oh, actually, after compression, there's still about 80 gig. So it's still a very big data set that we're talking with here. So from 200 gig of CSV is down to about 80 gig in FST format. Still a sizable set of data. And the way you work with data like that is basically just go, this is where I store the disk frame. So, so just to show you that the disk frame only contains the .fst files. And the way you use it is really just to say, well, this path is a disk frame. So just pass this path to the disk frame function. And now FM, standing for Fannie Mae, is just the disk frame. And if you print FM, it will show you some basic information like, okay, this is where it sits. There's 144 chunks. And each chunk, of course, is just one file representing one data frame. So imagine this humongous data set of 1.8 billion rows, actually almost 1.9 billion rows, is split up into 144 individual files and stored in this location. So, and this frame has implemented a few convenience functions, just like in base R, so n row and n column both work. So you can kind of inspect what's in there. So it tells you there's 1.8 billion rows and 31 columns in the data set. You can do things like head to inspect what the data looks like, just like normal, as if it's a normal data frame. But I guess one thing to emphasize is that at all times, the data just sits on disk. It doesn't get loaded into memory at all. And when you do a head, it literally goes to the first file. And the FST format is great because you can just say, load the first 100 rows, and it will only load that into memory instead of loading all 1 million rows and then filtering for 100. So it makes a huge difference in terms of performance. So that's why doing a head on this 1.8 billion rows data set, it's quite speedy, just like normal. I almost don't notice it. Of course, things like tails are implemented. So let's do a first really quick demo. So what I wanted to do is just do the equivalent of this in SQL. Basically, I want to group by this column. I want to sum this column, and I will just show the rest. Okay, so okay, just let me. Okay, I'll just go ahead and do that. Actually, what I noticed was that for some reason this is actually this is actually a newer file. So age. So I'm going to just do a quick summary. So basically, I'm going to change that. Own age. Mean own age. So if I look at the disk frame, right? So if I look at the names, yeah, of course, names is another function that's implemented. So you can see that these are all the names in the dataset. I really want to just take this loan age, which indicates like how long this loan has been around, I guess. Oh, by the way, Fannie Mae is a mortgage dataset, so it's all about the home loans, and so you see things like loan age. So I just want to take an average of that and count how many there are. Forget about this for now. And that's it. That's the SQL statement I wanted to do. And the way to do that in Diskframe is you just use the familiar group by statement, do your summarize, just like you would do with dplyr. And now you may notice this function here. This function here, I read this as source keep, but really what this does is it tells Diskframe to say this subsequent piece of analysis only requires these two columns. It doesn't require anything else. So when you do the processing, only load these two columns into memory. And to me, this is one of the things that I really want to improve with Diskframe, because theoretically, if you just ignore this line, Diskframe could have just analyzed this piece of code and figured out that, hey, the only two columns being used are this and this. So you didn't have to do this manually, but that hasn't been implemented yet. So for now, I would say the #1 speed gain in terms of working with Diskframe at this stage is to really just kind of look at your code and figure out which columns you're using and just say, okay, only load these two columns into memory using this source keep function. And this is how source keep is different from select, because select, again, it's not specialized in that it doesn't tell Diskframe only load those things. It actually loads everything and then select the columns that you provided. So let me just quickly give that a run. So you can see that it kind of finished really quickly, and that's not because Diskframe has finished really quickly. It's basically because it's lazy. It actually hasn't done any of this summary yet. It's basically just tell Diskframe to say, well, do this. And like other systems like Spark, to actually compute it, you have to call collect. So collect would just say, well, actually carry this out and bring the data into memory now. So let's just run that. Loan age is not, I probably just got the name wrong. Yep. Loan is loan.age, of course. Do that. Run again. Yep. Collect. Okay, so while that's running, I'll just show you what actually happens in terms of the CPU usage. So you can see all the CPUs, all the threads on computers are being used up. And that's why, how the Diskframe tries to be a bit more efficient, because it's operating on all 144 chunks simultaneously. It's processing collectively about 1.8 billion records, but it's doing it in a way that kind of tries to be efficient, because it tries to only load the columns that you need, and it's doing them in parallel. And if you have better performance SSD coming to the market in the future, like things like the Fusion drive, the 3D XPoint, you get even better performance. And it's doing a really simple trick. It's just loading data chunk by chunk into memory. And because it's doing it chunk by chunk, it's not loading all 144 chunks into memory. It's not going to overwhelm the RAM. So it's only going to use up a little bit of the RAM, as much as you need, and then just dies down. So that's how Diskframe gets around this limitation of working with larger than RAM data, because it doesn't load everything into memory at the one time. So as you can see, it can process about 1.8 billion rows, do a group by on that, just doing this simple summary in about 49 seconds. And the result is just, just like a normal deploy operation. So that's a demo of the data frame I want to give, and I want to just go back and talk more about the other features of this Diskframe before giving you another demo, but this time on a much smaller data set, so we don't have to spend so much time waiting for the operations to go ahead. So let me just go through the rest of the presentation. So now I've talked about Diskframe and how you can use it to work with 1.8 billion rows on your laptop or desktop. I think I do want to talk about when to use Diskframe and when not to use it. Diskframe, I try to implement as many deployer verb as possible for Diskframe. So you can just, once you convert it into Diskframe, it's fairly natural. So you can kind of do most of your deployer verbs. It stays in R, and I'll show an example later on where Diskframe can run native R code in parallel very easily for all chunks. And this tends to be a feature that's not in other distributed frameworks. So the other frameworks, for example, I believe Arrow, they would actually go ahead and implement all of the underlying R functions independently, but they actually do not call the R functions themselves. So what that means is that, for example, if you have a function that's only available in R, for example, like some sort of broom, tidy, then that would not be able to be run inside the Arrow framework. The Arrow framework only allows you to run the function they've implemented inside the Arrow framework, unless you bring everything to memory, of course. So that could be something that's you may want to just use Diskframe for if you have really highly customized R function that you want to run. And of course, it utilizes all GPUs, no complexity of setup. Really getting Diskframe is really just install packages, Diskframe. So you don't have to manage a cluster. I guess if your data set is not more than hundreds of gigabytes, then you probably don't want to get the complexity of a cluster management, unless you're lucky enough to be in a team where that's already managed for you. If your data set is too big, don't use the Diskframe. Diskframe is only meant to be run on a laptop or desktop. If you have things like BigQuery and you're happy with it, probably no need to use Diskframe because these things are pretty capable by themselves if you have the budget and the people that have already helped you set it up. Same with Spark. So, but from my experience, I just work with some clients in the past. They want to use Spark, but their data set is quite small, and they probably would have been fine if they used the proper tools on a much smaller system instead of trying to have a cluster of 3 and probably don't need it. And recently I've been really excited about things like Arrow and DuckDB. They're very promising options. I'll try to spend more time to kind of look at them more closely. Now, as I mentioned before, currently Diskframe doesn't work with CSV or Parquet directly. You have to convert them to a .fst format. But some of these tools, they can just operate. You have maybe 100 CSVs. Yeah, potentially you can just call into them and operate on them directly. But of course, I'm really excited about next month, the DuckDB speaker, they will talk about that. So I want to learn more about that as well. So, but I really haven't dug into these two tools really deeply. So I think this is my high level understanding. They may or may not be 100% accurate. One thing that I find really cool with things like Arrow is that they can support partitioning. So basically what they do is they, instead of just storing them as individual chunks of files, you can actually store them into folders, and the folders can have names attached to them. For example, one of your folder could be named with the month or day of the in the folder name, and you basically store all the data relevant for that date in that folder. So when you do a filtering or things like date equals to that, it will directly go to that folder and skip all the other folders. So that's another way to make things really fast. And this hasn't been implemented in Diskframe yet, but this is a very promising thing to implement in the future. So, so I've talked about some group by, which I think to me is the most important of the data manipulation operations. And you can of course do things like merging, left join, right join, inner join. You can do them in Diskframe, but it's a bit clunky at the moment. So I say Diskframe is not very strong in this area. I wasn't going to implement sorting of data frame because I thought, you know, in a distributed framework, this is not distributed framework, but in a large data framework, you really don't want to think about order of the columns. You kind of just don't assume any order most cases, but I'm very lucky to have a contributor implement this function anyway, for those that need it. If you really want to sort a big data set. So now I want to just talk about a little bit about the how to work with data frame. Just to summarize, you've seen this function before. First thing you should do if you have a CSV, just to say CSV to disk frame, give it the input files where you want to store the disk frame. And then there's some other options that you can read about in the documentation, which I've documented. But really, that's the first thing you should do, just convert any data set you have into a disk frame. And for a lot of data sets, you can just go, okay, a disk frame is composed of chunks. So in the last example I showed, it's got 144 chunks. And a lot of data operations is like you have a big data set, but every month you want to add some new data to it, and you would just call the add chunk function. So add a chunk to a data frame, you can just do that. And it's a great way to convert SQL databases to disk frame. You just basically set up a disk frame, get some data from the SQL database, but set a limit, set an offset, convert that to a FST file, and then call add chunk, and then go to the next one, and you keep going. So in this way, by using add chunk together with the disk frame, you can you can basically copy from an SQL database to disk frame, just a side note. Okay, I finally explained this concept of the shard key that you may have seen. So what the shard key does is it takes whatever you choose to be the shard key. In this case, I've chosen loan ID, so shard by loan ID when I do the conversion. So what it does is it computes the hash on the loan ID, and it makes sure that the loan ID with the same hash ends up in the same chunk. So what that means is if your loan ID is ABC and your hash happens to be 1, then you're always in chunk 1. You'll never be in anywhere else. And a lot of the analytic operations is concerned with, let's compute the average balance of this customer or the average loan size of this customer. So it's always, almost always, a lot of the time you're always doing things like group by a particular customer. So if you sort by the customer ID, then those operations will be a lot faster. If you kind of already start by storing them in the same chunk in the first place. So you don't have to do any cross-chunk communication. So to summarize for the customer, the process only has to go to one chunk, summarize it, and that's it. And you got your summarization. So choosing the shard correctly is very important for performance. And this is true for other systems as well. Like I believe in a system like BigQuery, this shard concept is called a clustering concept. It's the same concept. So that's what the shard key is. And it's basically, you have to be smart about how you choose a shard key. You don't want to choose something that's very skewed. Like if you have a categorical column, one of them is 70% of the data, the other ones are smaller, then that's probably not a good choice for a shard key. You probably want them to be highly random and uniformly distributed once you run a hash function on them. Okay, but that's just, okay, so let's do another demo now after talking through about some of the theories. So this is a demo. This is going to be a much smaller data set, so I can run through them very quickly. But again, every time you start using Diskframe, this is what I recommend. You do library. When you do library, it'll print some instructions the first time you run it about what you should be doing and like how many number of workers is available. And the number one thing I recommend once you do a library Diskframe is to call this function, setup Diskframe. And what this does is it'll basically start up a few R sessions in the background, so you can use them for parallel processing. So that's one thing. So I have this data set here. It's a criteria data set. It's a marketing data set. And I'll show you what it looks like. It's a much smaller data set. It's only 3 GB in size. And I'm going to do the same thing. I'm going to load this CSV into a converter to a Diskframe. Optionally, you can specify an output directory if you want to keep this Diskframe permanently. But if you don't set this column, what will happen is that it'll just store the Diskframe in a random location. So I'll just run that. It's converting a 3 GB data set to CSV. It's reasonably quick. And once it's created, you can actually look at the content. It'll tell you that, hey, this data set is stored in this temporary location. That's because I haven't specified a proper output directory. And that's how many rows and how many columns in the data set. So basic information. Again, you can run things like head to see exactly what the data set looks like, just like normal. And again, I want to just do a summarize. So this is a much smaller data set. So if I don't do source keep, I can still summarize it in a reasonable amount of time. So I just run that. I'm just doing a group by all of these columns and just doing an end. And I think in dplyr, you have the convenience functions like count, but I'll just show you exactly like what this does, but the count should also work. Okay, so you can summarize it in around 10 seconds or 8 seconds. But if you do source keep, meaning I recognize that this operation only requires these 4 columns, so only load these 4 columns, but otherwise it's exactly the same operation as before. If you run that, and now the time is down to like 1 second, 2 seconds. So huge performance boost if you tell Diskframe, if you spend the time to tell Diskframe exactly what columns to load. So you can kind of skip a lot of the expensive loading data into memory operations this way. So it's a lot faster. Now, I want to show some deploy operations. So the first thing I do is I'm going to do a filtering. Let me just show you this. Now, again, a lot of these operations are done lazily. So you run it, it's kind of immediately returned, but it actually hasn't done anything yet. And you need to call collect to do it. But really what I want to do is figure out how many rows there are in this under this filtering, because this is the treatment group and exposure. So treatment is the criteria at this data set is basically they're running a marketing experiments, and some people they show the ads to, some they don't. So the one they show the ad to, it has a treatment equals to 1, otherwise 0. But if you show an online ad to someone, doesn't mean that they are always properly exposed to the ad, or maybe just they didn't even look at it. So so they also include a column called exposure. So exposure equals 1 means they have interacted, for example, interacted with the ad in some way or whatever it may be. But this means effective exposure to it. So I only want to look at those that have been effectively exposed to the ad, and just work out, how many there are. Just summarize, collect, and pull. Okay, this many. I want to do the same thing to the control group. These are people that I haven't shown the ad to. Just figure out how many there are, and I work out a ratio. Okay, okay, and let me see if this is working. It was there was I ran into some R bugs in the past, but it's a bit temperamental. So anyway, so you can just do normal operations. In Diskframe, we've implemented this sample fraction. So if I want to sample from the control group exactly this many records instead of so I want to do some downsampling from this number to this number. This is what I would do. I just call the sample frac function. Just took the ratio of the two, and I can just compute the computer fraction of it. Now this is where so say I have the effective exposure data set, which I've created here by using this filter, and I have the control group, which is done under different filtering rule. So I want to combine these two data sets, do a row combine. So this is what I do, just do rbind list, Diskframe, the two Diskframe I want to combine. And once I combine them into one, I want to create things like a target, which is this formula, and select. So you can see I'm just doing normal dplyr operations. So once you bind two Diskframe together, it will basically take the two Diskframe, put them into one, and store them on disk somewhere. So maybe I just separate this step out first. Modeling data temp, and do it separately. Show you what happens. So I run that. When I run that, it gives me a comment saying, okay, it's appending the two. And so Diskframe data temp, which comes from here, is also a Diskframe. So I'll show you what happens. Again, it's done the Diskframe at some random location. And the number of rows you can see here is, you can guess, is just the sum of this and this, because I literally just combined two data frames together. Actually, it's a bit bigger for some reason. Anyway, okay, I'll check that later. So it works. It just combines the two together, and then because this is also a Diskframe, you can just do mutate and select as you normally would. So you can just see what happens here. Creates this frame. And this is something I want to show, which is that if you want to apply arbitrary functions on the data frame, this is what you call Cmap. The C in Cmap stands for chunk. So this is following the per syntax. For those who are familiar with it, syntax. And what it does is basically it says, oh, give me this Diskframe. For each chunk in the Diskframe, apply this function. So for those of you who are familiar with it, this is the per syntax for defining a function. And .x is basically the first argument to this function. So you don't have to type the function keyword if you use the per syntax. And what it's doing is it's calling GLM. It's feeding a model on the target using all the columns. And of course, the data is each chunk. And I'm going to finish off by returning a broom tidy of the GLM models. So a broom tidy is very handy. It takes the model, and then it converts the return of the model into proper data frame. So when you fit a GLM, normally it's like normally fit a GLM like, it's like Maybe just do an LM just to show you the case. Yeah, so you get something like this. And so broom tidy is very handy in that it will take that and kind of converts it into, it returns a table of the information that you see. So yeah, because it returns a table, then you can manipulate the table. So that's what broom tidy is. It's purely an R function. It's not available in other objects or other languages. So for example, if you do used arrow or DuckDB, you're likely not be able to call this unless you bring the data into memory. But with Diskframe, you can just put in R code. And that's kind of one factor where Diskframe is a bit distinct in that you can call R code directly on the chunks. So what this code does is for each chunk, fit this model, but return the outputs in a table format. That's all it does. So I just run that, and hopefully no weird errors. I've been running into weird R errors that kind of tends to be resolved if you restart R. So maybe some issues with the newer versions of R, or some package is broken or something. I'm not 100% sure, but it typically works. I just go through the data, fit a model, and it will collect the models. And if you recall, because each broom tidy returns a data frame, when you collect it, by default, the default collection for Cmap when you return data frames is that you'll combine them together. So this is, so that's why you see a big, what gets returned is a big data frame, just the row bind of all the outputs. And that's the default behavior of Cmap. In this frame, you also have functions like Cmap, things like collect list. If you don't want some of the default behavior, you can just call collect list instead of collect, then it will return the results in a list. So you have things like Cmap, DFR. Sometimes you want to be really explicit. You just call it Cmap DFR, so data frame row bind. Of course, for those who are familiar with per, this is just the same as the per map DFR, except in Diskframe, I decided to put a C in front of it to make it clear that we're operating on each chunk. So that's something about, okay, so I've returned this table, and maybe I just want to do a simple ensemble, which is averaging all the coefficients I see, for example. So because now this is a data frame, I just use normal multiplier syntax. So this frame is very, very, very convenient for doing things like that. You have a big data set, you distribute them to small chunks, you fit a model on each chunk, assuming that your chunks are distributed correctly or sampled correctly. Then you can just create really simple ensemble models, like some type of backing models, for example, just by returning the fitting a model for each chunk and just combining the results together. And of course, but some of you may have come across the speed GLM packages or the big GLM packages, or it's called big LM packages. And these are packages that can take a large data set, for example, talk to a SQLite database and fit a model on the whole data without doing some kind of averaging like I've done here. And I've implemented a function called df-glm. So df, of course, stands for Diskframe. And GLM is just the normal GLM. I use the normal big GLM syntax. Unfortunately, in this syntax, you can't do a dot, but that's not necessarily a limitation of the Diskframe implementation. It's more because the underlying implementation, like big GLM or speed GLM, also don't take a dot. So I kind of just did not try to be too cute and try to expand the dot and do all of that stuff. But it's really just this. It's a convenient function that calls into the underlying packages. So so if you want to do the convenience of fitting it on every single column, you might want to just write some loop to construct the formula, but or use some other I believe some techniques where you can just construct this very quickly. But anyway, just call df-glm. It will just go ahead and fit the models on this large data set, and it does it in a way that doesn't break the memory, because I believe the packages that implemented the GLM for these also loads the data chunk by chunk and kind of just goes through the data and still come up with the right regression. So yeah, so it's finished. And you can do, say, summary on the model, just like normal. So just one big model. And you can see that it says it's a large data regression fitted by this formula. And it's fitted on the whole data set there. So yeah, so I see that there's a couple of questions here. Is the data stored on your local repo? The data is stored in my local folder actually. So in this demo, there's no use, not using anything like you know, your S3 buckets or whatever. It's just literally all the data is stored on my local laptop computer. So it's loading from my local computer. Where to put 200 gig on your local? You don't even have 200 gig of data on your local C drive. Okay. Yeah. Well, I think it's quite common to have maybe 500 gig. Yep. Of even on yes. You're not, don't ever put Diskframe on a shared drive or like a network drive. That's not going to work. You really, because the network transferring a lot of data from network is not, which is not great for performance. That's, yeah, you really need a local SSD where you store the data. What would you do is the original data is stored in chunks in the FSD format already, but metadata doesn't exist for disk frames. I think that's perfectly okay. So like really simple demo would be like, what if I have a data frame, you know, just 3, and I'm going to use the FST package to write it out as an FST data data. Actually, I just write it here. So if I go to my data folder, I just create some random folder called testing 2. Yep. And I'm just going to write the data set to that. Yeah, so that's one data set. I call it testing 2 1 FST. No metadata whatsoever. It should just work. So 4 to 6, whatever. And so now this folder should contain just 2 FST files, but nothing else. So I should be able to do a disk frame to it. No issues. So if I look at the content of df1, it'll tell me that df1 has 2 chunks, 6 rows in total, 1 column. Yep. So the dot metadata is not necessary. Diskframe can create it if it doesn't see that folder. The important thing is just the individual files. Apologies for the docs. Okay. So yeah. So I've gone through. So basically, the point of demo is that you can use dplyr verb that you're familiar with, and you can also run R code directly using the Diskframe framework, like for example, using the things like Cmap, etc. So that's what you can do. So just to recap what's happened in some of the code, you see that once I do a library of Diskframe, the first thing I do is set up Diskframe to say how many workers. You can optionally say how many workers you want. By default, Diskframe will look at your laptop, work out how many CPU cores there are, and just use that number as the default number of workers. So each worker is basically an R session that sits in the background. So every time you run something on a Diskframe, you'll try to send the work off to these workers. So for example, when you have 144 chunks, you do a filter. It will just send the filter to each of the 6 workers, and each worker will do a filter on a different chunk and return the results. And a lot of the magic that happens in that, it's done in the future package. So yeah, this thing probably wouldn't have existed without the future package, which is quite awesome for easily distributing workload like that on a single laptop computer. And of course, the way once you have a folder of FST files, to make use of it in R, you just literally call the diskframe function to convert this folder to a diskframe. Then you can start operating using the deployer of verbs on the diskframes. For there's some support in diskframe for data table syntax, but the support is at this stage not as prioritized as deployer, but at some point we could pick it up again. And these are just a selection of functions implemented for diskframe. And number one takeaway for now is this source keep function. Just always, if you know exactly what columns you use in your operations, keep only those columns into memory. That's going to be really speed things up a lot. Okay, so I think I've gone a bit over time, but and I've talked about Cmap and how to use them, and I have some slides, and of course I've shown how to call GLMs for diskframe. Potentially, you may want you could do the same tricks for like things like XGBoost or neural networks, basically pass chunks of data to each of these models and fit models using fit neural networks and boosted trees using the diskframe framework. I have done some proof of concept. They work to some degree, but they're not really emphasized at the moment. The only implementation of statistical or machine learning algorithm I've done is just the GLM, which is backed by these two packages. So that's it. That's all contents I have, apart from the ones in the appendix. But yeah, any questions? Happy to take questions now. Questions.
Thank you very much. I'll give you an applause since again no one else can right now. We have a few questions. Actually, there's some other questions that you answered not by reading them, just in your presentation. You answered it later on. So I'm going to skip the ones that you've already answered without realizing you're being asked.
Yeah.
So first up, this is let's see. Well, this is curious about your rig. How many cores does it have?
This one has 6 cores.
6 cores. Okay.
So
cores or threads? 6
cores, 12 hyperthreads.
And I'm going to do a follow-up for this person's question.
Yeah.
Do you see a performance like decreasing gains by once you get past physical cores into threads?
Physical cores into threads. So,
like I know, like for like some like tree-based algorithms, like using more than the number of physical cores doesn't really do you much better. Like once you start using, like if you have 6 physical cores, using 8 threads doesn't do you much better than 6.
Yeah. Yeah. So my CPU has 6 cores, but 12 hyperthreads. So each core is hyperthreaded. But if you look at when I do the setup, the setup will tell me that I'm only starting up 6 workers. So I think from my testing, it's that even if you have 12 hyperthreads, it's probably not a good idea to use all 12. You're probably better off just starting 6 number of workers as you have actually physical cores. Yeah, and of course, sometimes it's sometimes your program is CPU bound, but a lot of the time it's just limited by the speed of your SSD or hard drive. So yeah, it's basically sometimes Diskframe just can't load data into memory fast enough. So sometimes even if you're running an operation, your CPU doesn't get overheated. It's just because it's loading data is quite slow. But I think there's better and better hard drive technology coming into the market. So those things could really be really interesting going forward. Yeah.
Well, what do you do if one of the chunks is bigger than memory?
That's a good question. So typically, when you do the conversion, when you run this function, there's a function in there that try to guess what will be the right chunk size for your particular laptop, and so therefore you can do that. Now, if it just so happens that you created the chunks on one computer, you kind of shift it to another computer, that just doesn't fit at all. Now, there's an implementation of this function called rechunk in Diskframe. So what the rechunk does is basically says, well, you have 100 chunks to start with, break it up into 200 chunks. So you can do that just by saying, fitting in the right parameters. So for example, I could rechunk my Diskframe as maybe n chunks df times 2. And if the algorithm is smart enough, when you do something like that, it should be able to just load maybe half of each Diskframe and write it out. But of course, that would require some kind of programming support in how you do that. So it doesn't do that perfectly. Diskframe does kind of assume that you're working with computers. When you move it to another computer, it's kind of a similar power, but obviously that doesn't always work. But you kind of, the great thing about FST is that you can kind of read part of the file. Like you can just go, from row 1 million to 2 million. So you can read chunks of the data, and then I guess you just read chunks of it, write it out, and then you resize your chunks, potentially using the rechunk function. But there's no easy way to deal with that, I guess, if you're moving computers. But within the same computer, you can probably use some functions like n chunks or in chunk size to control how big the chunks are. I haven't had issues with this one, but this is a pretty chunky laptop.
Okay.
Yeah. Just to say, result written back when you join. Yes, when you join it, it's written out as a new one. So so when I did the R bind list, it's taken these two, which sits at 2 different locations, and outputs it in a temporary location like this. Yeah, so by default we should do that, because otherwise there's no other logical way of doing it if it's not written out to a different location. Yeah, because you obviously don't want to overwrite these things. Yeah.
Speaking of our bind list, that's very much from data table. Can you use bind rows?
I believe I haven't implemented bind rows, but yes, I had. No, I haven't implemented that, but yeah, I probably should at some point. It's the same kind of thing, but from the dplyr world. Yeah.
There's an earlier question about, are you only using physical SSDs, or do you still get performance benefits if you used virtual machine local drives?
Virtual machine local drives. So I'm not 100% sure about the technical details. So for example, if you're talking about virtual machine and got some sort of EBS attached to it, and the EBS maybe has a really high speed network to the virtual machine. I haven't tested out extensively, but yeah, it should be the limit should just be the limit of the transfer. So because Diskframe actually doesn't, the speed of Diskframe is really determined by how fast it can transfer data from A to B and then into memory. So if that connection is fast, then you should see the performance benefits. But I'm not 100% sure about the technical details about what you mean by local drive on a virtual machine. So of course they have to be physically or close or have a huge connection between the two. If you have those properties, then it should be as fast as those connections are. Yeah.
How would you did sort of touch upon this, but I think it's a slightly different question. How do you calculate metrics such as median or quartiles? And you did that's essentially sorting, which you touched on.
Yeah. So if you look at the things like Arrow, they explicitly mentioned they used an algorithm called DT digest, which is a approximation of the median, because to do median, you need to do sorting. So if you look at the documentation I have on group by, you see that when you're doing a group by, this is on the Diskframe website, by the way. So for these functions, the computation is exact, but for median, things like median, quantile, IQR, they are an estimate, because as you imagine, sorting a 1.8 billion row data set is just too expensive. So we tend to just use estimates for these. And this is this is true for almost everything, like Spark does it, Arrow, I believe, I read recently does that. So it's kind of like a limitation. But I did some tests on some real world data sets. It's surprisingly close. The median is actually to the actual median. It's like sometimes there's no difference. So yeah, correct, can't be done. It's an estimate. Yeah.
All right.
Yeah.
Cool. Then can you use SF objects with Diskframe?
Sorry, what object?
SF, they're like spatial data frames. Like
okay. I get asked that a lot actually. I honestly don't know enough about it to say, but I think I just don't know. But I think Diskframe as of now works directly on FSTs only. So
and FSTs, I don't think you can save SF objects as FSTs. Now I think about it.
Well, I don't know how FS are stored. Are they stored as data frames? So I just don't have that knowledge to answer that. So yeah. Yeah, so unless it can be stored as an FST or in some table form, then the answer is no. Yeah.
Okay.
Yeah.
And this one's for me. You mentioned XGBoost, you haven't implemented yet. Yeah, I think they have a like that special XGB.D matrix format can actually be written to disk instead of memory. So it sounds like it wouldn't be a huge leap, not knowing all your crazy architecture, to get it to read your FST files.
Yeah. Yeah. No, I actually have done a proof of concept, just pushing the data into a XGBoost. It's worked. I've got some code lying somewhere, but I had some issues with it, like in terms of like performance, and I just didn't have the time to look into it. But as I mentioned, XGBoost neural networks are possibilities, but it's just that the best performing ones are the GLM. So I just kind of stuck with that for now. Yeah, I actually written some code and I demoed it in other places, but it's a possibility, but not something I probably really, going to immediately work on, kind of thing. Yeah.
Cool. So another question just came in. This is probably an answer to what we said before. They're answering the SF question. You can say, well, I'll read it for everyone else. I'll read it for everyone. The SF package geometry columns, which are list columns, they cause write FST to fail if this error message.
Right.
Yeah.
So I guess the question is, can those columns be written into a format, for example, like Parquet? If they can,
yeah. Parquet, they theoretically can, but there's like a known issue that they can't. So someone wrote a geo arrow package to make it possible. But as of right now, Parquet doesn't nicely do it without this geo arrow package making it happen.
Yeah, I see. So I guess one of the things that I think Diskframe will want to move towards is to be able to work with other formats than FST directly, because actually the infrastructure is the same. The code is almost the same. So if the dataset can be at some point written to something like a Parquet or some other format that's kind of can sit in chunks, then yeah, could be adapted. Diskframe could be adapted, but because I've kind of no knowledge in that area, SF never worked in that geo area, kind of not something that I'll kind of jump into and say, oh, okay, I want to implement that. But yeah, I've been asked that a lot. I might look into what that is actually about and see what can be done.
I think I might have even asked you that on Twitter at one point. So.
Yeah, maybe it's sometime in the future, but definitely not in the near future. Not something like yeah. Okay, SF format is compatible with Arrow. Is it? Oh, I'm not sure. Okay, not sure.
Sort of. They say it is, but there's like a known bug that it's not. But there's this person who I don't remember their name is working on geo arrow. Geo arrow is what they're calling it, I think. So hopefully soon.
Yeah.
So since you sort of mentioned rapids earlier, think we're ever going to get Diskframe on GPU?
That's an interesting question. Theoretically, if there's a convenient way to call GPU functions from R, and if your data continue to sit on disk, then you could potentially see where you call R. As I mentioned, you can just call R code from Diskframe. So like here. So imagine if there's a GPU function that reads the data and do some processing. and that function is available in R, then yeah, potentially you can just call that in Diskframe, or and Diskframe could potentially make use of that. So for example, suppose you have a function called GPU group by, and that group by takes input from some data input, whatever it may be. And suppose this data input can be chunked, then I could just create a Diskframe version of this, like maybe Diskframe or Diskframe, something like that. And it will make use of the GPU functionalities directly, because I'm literally just calling R code, potentially. But I haven't seen that kind of development yet, or maybe I just haven't been kept up to date on what's happening with the GPU side of things. And I had, honestly, I had a few issues trying out those GPU data manipulation packages. They tend to be a bit harder to set up. Sometimes also doesn't work that well on Windows. And potentially, for a lot of the operations, because the GPU memories are quite limited, you end up having to do a lot of gymnastics about how you move data around. And I think there's a benchmark somewhere that shows that GPU doesn't always win out all the time at this stage. So I say it's an area to watch how well they become, how much better the technology becomes, and how easy it becomes to use. But I honestly don't know enough to talk more about that. It's just I only talk from my kind of how I feel when I try them. It just yeah, it's work in progress, I say. Yeah.
Cool. Yeah. All right. I will give everyone else just another minute, see if there's any last minute questions. There often are that slide in underneath the wire. While I wait for anyone, I guess, to ask a last minute question, I just want to give another round of applause to ZJ for coming and giving this talk. So thank you, everyone. If you want to throw in some clap emojis, whatever you'd like to do. And I think this is an excellent presentation. We had a bunch of extra memory formats, and it's pretty cool to see this. And we'll see next month about DuckDB. We had a long string of them. I see you're pulling up some benchmarks from H2O. Yeah,
I believe this benchmark may have been kind of defunded recently. I'm not sure, but yeah, CUDF, it performs quite well, but you wouldn't say it outperforms the more traditional, not more traditional, the the new kids on the block like Polars and data frames in Julia, like just by looking at so yeah, it's not it doesn't feel like it's gonna blow existing tools out of the water just by looking at this. Yeah.
Very cool. It's always good to see some reality checks when you're talking about this hype.
Yeah.
We did get another question sneak in. Do QS objects need to be changed to CSV before they can be changed to FST to use Diskframe?
I don't think so. If my memory serves me right, QS is kind of like a new thing that people have started using to save the RDS file. So like it doesn't have to be like, imagine if you just have a bunch of files in there, like QS files. You can just, for example, do like even lapply would work. Just say, and then you have a function called QS file, and then you do something like read QS. I can't remember what the function was, but QS file, and presumably at this point this would be a data frame. Then what you do is you just go add chunk to df diskframe. So okay, and you would do something like Diskframe would be set up here. Diskframe would be a Diskframe to this location, XYZ. Yeah, then you just call this. It doesn't have to be converted to CSV first. You can just read it directly. Call add chunk to add it to the Diskframe, and that's as simple as it gets in terms of converting non-CSV formats to Diskframe. Yeah, yeah. QRead. Yeah, I haven't used those packages extensively, but you get the idea. Kind of that's just call add chunk and just literally read this and add it as a chunk to Diskframe. Yeah.
Nice.
Of course, you can also do things like once you read it, so as disk frame. So you end up with a list of disk frames here, and then you just do rbind list disk frame to a big disk frame, something like that. So you can just, yeah, if this is a data frame, just convert it to a disk frame using this function. So you end up with a list of disk frames and just rbind them. Or, you know, if you want to be cute, you can do future, you know, future apply to do it in parallel. It's possible. Yeah.
Mm-hmm.
Yeah.
Interesting. And I think we should all give a round of applause for all the live coding we've seen. And it's always a perilous journey doing live coding, and you've done it with fun. So that's great.
Yeah.
Cool.
All right. Thank you.
So I think we've wound through. There's a bunch of questions I didn't ask because you just happen to answer them during your talk. So like we will not even touch them. Like there's just a bunch of things someone asked and you just happen like 10 minutes later to answer it. So we won't even go there. I mean, I'll just give you a hint, like asking about like network drive. Well, you answered that one, but there's other questions about like data table syntax, and you just happen to show the data table syntax. So there's a question about like map, and you showed Cmap. So you covered all the questions without even knowing them. So that was awesome.
Yeah.
So yeah, so thank you very much for being here. We see someone saying, Walter saying live coding rocks, and it does. So thank you very much. Thank you for being here with us. Thank you everyone for attending. We look forward to next month. We have DuckDB. The following month, we have the Brooklyn Bridge. We have the conference in June. We have jobs at job postings. Lots of good stuff happening. So before we leave, just everyone, one more just round of applause, virtual applause for ZJ as a very big thank you coming to us from literally not all the way around the world, literally halfway around the world, in both directions. So thank you for coming to us and spending your day with us.
All right, yeah, my pleasure. Thank you very much.
And everyone, see you next month.
All right, see you guys.